This is Shri. This is my project Pramaana, and this is my mock demo day presentation. Yes, I'm still working on the project, and like it's currently in a state of like everything's been implemented, but it's in like different parts and pieces, especially the implementation of PyCrits part. So this is my presentation. So my whole goal is to prove that you're real while you store nothing. It's a post-quantum proof of unique personhood built on identity system at a population scale. So the one of the biggest problems is the world's biggest ID systems literally store everything. They are centralized by design. There is a single authority that holds the demographic biometric records for over a billion population, and the stored biometrics cannot be reissued. So once a password can be reset, but a fingerprint or an iris cannot be reset. So if there is any retention, that means a breach can really collapse the whole system. And classical crypto and quantum horizon is one of the things that people haven't been using in this regard. So the records that are collected today are decryptable tomorrow, and they're like harvest now, decrypt later. And there are like population scale registries that are the highest value target. So one of the technical insight is that a national ID number is not a secret. So in our own paper, the PII is used as a cryptographic anchor, taking this national ID and taking and creating a 256 bits of minimum entropy, and this government ID numbers do not come close. Right, there's like 12 digit national ID, then we have name and date of birth, and required by the same we actually need 256 bits. So 2 to the power of 180 is the gap between the real ID tuple and what the cryptography assumes. So here the solution is to have a password manager that actually stores nothing. So Pramana turns like real unique word in identity into a quantum safe commitment. It proves that you're a unique alive human, then erases everything that is used to know that. So the PII is touch once. It's used as like a one-time entropy, then it's cryptographically erased, and it's like a one-way construction. It's also quantum safe address, so it works on MLKM 1024 lattice commitment, and the registry breach literally can reveal nothing. And it's also Sybil resistant, so one document can only provide one identity, and it's enforced by cryptographic binding and not by a trusting operator. Just to give you the demo of the PRED itself, so this is Pramana. It's also version 3 where I have created a protocol using this paper, the face-to-face NIR facial recognition system, and how we can use it in this context, and also like made sure the cryptographic schemas and the whole identity proofs are completely robust. So this is like the whole thing that I have also previously built. So this is to analyze your wallet for your cryptographic safety in terms of like a quantum threat. So here it reveals like where the public key exposure is at. We can also check like different transactions, the contrasts, and also we can see the Sybil demo by creating like 5 different burner wallets and trying to enroll into stuff. And here we can like run a Sybil resistance checks, right? So no Pramana enrollment can be found based on this wallet, so it's not quantum protected. So here the wallet identity versus Pramana identity, here it's like requires unique PII, and we have only one identity per person. There's like unlinkable pseudonyms. It works on Kyber 1024, and there's only one commitment, right? And here is to enroll. So I'm just gonna use my government ID, and I'm gonna select like the Indian jurisdiction code because I'm kind of trying to like redesign this entire schema around Aadhaar card. And here for the SHA biometric template, here we can choose a document. For now I'm like choosing a picture of mine that's like clear. And also like using, this is typically found in your passport. Right now I still have to build like a computer vision model that can fetch these details in, but for now we can like copy paste these details from the passport. This is for a biometric verification check. So it also uses the device's biometrics like Touch ID. And it also uses your device camera for the NIR detection. Right? So it kind of is mapping the light that's on my face right now rather than my facial features itself. So here we have the document that's been validated, the hardware liveliness is checked, the RGB liveliness passed, and the face actually matches to the document that I have uploaded. And currently I have to work on like connecting wallet and enrolling this identity on chain. So this is gonna be here as a biometric cache, and this is optional whether you want to have it or not, but it will just add a level of robustness to your security. And we have this PLC commitment, and then we have the on-chain registration happening. While it registers on chain, I can continue with the rest of the demo. So this is a password manager that literally can store nothing, and it is based on your facial verification. And then here, this is the PLC commitment pipeline. So first we hash, then we stretch the hash, then we bind it, then we derive the key, then we generate the MLKEM key, and then finally we commit the commitment C. So once we take the PII seed and the secret key, everything is wiped out from the moment of the commitment that exists. So the device seizure recovers literally nothing. And it's proven and not asserted. The hiding, binding, uniqueness is one-wayness, and it's proven under MLWE, and it preserves all the 6 ASC U2SSO security properties. And we kind of survive the 36-bit secrets by having an argon 2 ID stretch. And this is like a deterministic commitment over low entropy PII is like kind of guessable. So we are like making different layers so that the guessing is economically impossible. So one of the stretch is like the argon 2 ID stretch, then we have the blinded OPRF, and we also have rate limiting. And it's an attacker would need the server key and an enormous compute and unlimited online queries for them to retrieve these 36-bit secrets. And PyCreds is Python proof of concept. So this scheme isn't just in theory. It refers the POC implements and PLC end-to-end against like real NIST primitives. Here we are also using the liblox MLKM 1024 and SHA-512 HKDF key, and we also have like the sub-millisecond commit with like 1568 byte commit. And here why exactly this matters is that here we have 1.4 billion people at 22 TB amount of data. So to create a quantum safe registry for a nation, we need to have it fit on a laptop's drive. So PyCreds plays an important role as a proof of concept in this particular scenario. And here we are starting from a paper. This started as implementing a research paper to actually building something that people can use. So here on the device we have the document, which is like MRZ verified. We also have the hardware liveliness and face check. We also have face match in memory based on the identity document that you have submitted, and we also have the PLC commit and erase. And we also get the stateless OPRF key generated from it. So we have one key, and we don't need any database, we don't need any logs, and nothing can leak no matter what. And finally we commit it on chain, and it's like an on-chain registry. So we have it live on Sepolia, and it's got PK key novelty, and there's no odd admin code key, and it's also bytecode verified. So this is like the digital public infrastructure. This is one of the use cases that I'm going with, especially being affiliated with the Amravati Quantum Valley. I felt like if I can think in a perspective of employee verification and like onboarding without having like to store the details about the employees and still have a background check, that was like kind of the realistic route that I was going in. So one of the biggest challenges is the scale. There's like literally 1.4 billion people in the country, so we need to scale these systems up. So here we have like over a billion enrolled identities. We need to make the registry the highest value target on earth, and it should also be the safest database that actually shouldn't exist, right? And it should also have verification without surveillance. So the service providers learn that this is a unique person and a real person and nothing else. That should be the end of it. And it is quantum safe from day one. So the registry is meant to last decades and must outlive the classical cryptography MLKM standard answer. And it's drop in and not rip out. Pramana replaces the enrollment anchor and not the whole stack. It slots into like the existing DPI as a registry layer. And here, one of the ecosystem finds that we have is the collaboration with Amravati Quantum Valley. So India is building its first dedicated quantum technology park in the same country that runs the largest identity system. So that's where the threat and defense would meet. So here, this is the foundation that laid in Feb 2026, and I'm one of the affiliates of it. There are like IBM, TCS, and L&T partnered to this IBM quantum systems, and we also have like a quantum reference facility that's commissioned in this April, and this part targets at roughly 1 billion in investments. The named focus areas include like cybersecurity, healthcare, defense, and finance, and a whole state quantum talent mission. So why exactly Pramana would fit this cape is that the defensive half of quantum, the AQV builds quantum capabilities, the post-quantum cryptography is where it protects from everything that capability threats, and identity is one of the highest stake targets, and a billion record registry is the first thing that will have an adversary harvest today to decrypt later. And there's also sovereignty and standards that are aligned. So we have MLKM under FIPS 203, and it's like formally proven, and there's no foreign dependency in the scheme itself. So here it's the employee verification and background checks for the Quantum Valley is one of the approaches I'm taking with Pramana. So remote hiring kind of broke the identity layer. There are like deepfake candidates, borrowed identities, infiltration by state-linked actors are like now new thing. And the fix today is to handle a screening vendor so that you can see your entire life. So here we have the screening vendors that retain the essence, the address, employment, criminal history, and everything in bulk. And one vendor breach means millions of candidates who like registered with those vendor or interviewed with these vendors are like literally screwed. So nothing in this process kind of proves the person that video call is person on the document, right? And the contractors and ghost employees past this uniqueness is never really checked. With Pramana, we have the liveliness bind to the live human based on the identity document. The uniqueness proves only one person and one hire and no ghost employees, and the employer gets a verdict, not a doser. Like it's kind of verified and unique and live. There's zero retention, so zero breach, so nobody's identity is at a threat. So this is where it kind of in terms of like product to market fit, I'm going for the Web3 Sybil resistance accept aspect for like airdrops, DAO voting, deepen, AI agent verification. And here we also have our advantages in this field because we are like wallet native, zk compatible, already on chain, and also fast sales cycle, and it can be used as an SDK and utilized and packaged as a singular endpoint that you can have so that you can check proof of unique personhood. And also fintech KYC and age checks, that's one of the biggest things that we can do again. So onboarding, age verification, like you have like faked your age in so many different platforms like Facebook, or like registering with different platforms that would require age checks. So we can actually implement it so that we can check somebody's age based on the document details and their face matching and liveness matching, and we can actually predict people, and we can like never leak whatever is stored, and the increments cannot copy, and like the retention is the model of most of the things that are in the market right now. So here the model is priced for verification, enterprise tier on breach liability reduction. So three tailwinds, and we have quantum urgency, then we have privacy regulation, and proof of personhood. These are three different aspects that I've been working on in integrating with Pramana. And their limits are stated plainly. The document authenticity is something that we can't check because it's issued by the government. So we should take the government document and believe it's true. Like even if you're going to a platform and like somebody uploads their passport, we just assume that the passport that they uploaded is true. But still we are doing like a face liveliness matching based on the passport image and our own face. And the browser liveliness, there's like an RGB challenge response to real-time deepfakes injection. So I am using an OS level NIR on capable hardware today today, and with like a native app platform attestation next, and also client trust. So here we are working on app attest and play by integrity or TE signed enrollment, so that we can actually ensure that the on-chain registration can't enforce checks in a browser. It's an identity and never stores history. So when we prove we are unique in live, and we do not like want to know if you have a criminal record or like a mental health history or something. So it's an identity anchor for a screening process, not a replacement for the screening itself. So this is the traction. So it's for a formal scheme and security proofs under MLWE, PyCreds, POC, Unreal, LibLox, MLKM 1024. The V3 pipeline made the PLC robust. Argon 2 ID and OPRF are adding as layers of security. The Pramaana is deployed and verified on Sepolia, and yeah, it's asking for like design partners, DAOs that are interested in connecting for airdrops and stuff. It's an independent security review before any paid pilot, a cryptographer so that somebody can review the PLC proofs before pre-publication. I also got the introductions to Amravati Quantum Valley, and that's like a standard now. So the main idea is that 1 billion people shouldn't have to be stored just to be counted. So this is what Pramana solves, and this is what I stand for. Thank you. And checking the enrollment, it's must have been done, and we also will get an attestation certificate, and we get the enrollment proof, and we get the compatibilities. Then we can also verify it. It's also like an unlinkable odds, CKB generation, pseudonym derivation, and this is our master identity key. We can also like go ahead and like register the pseudonym, and we can also check somebody else's identity registration. This is for like enterprises and stuff, for to check somebody's identity whether it's registered or not. And this is also like the on-chain metrics of what's happening, what are the different transactions and everything. It's like quantum safe, and this is like the basic dashboard that records all the different events that you have done, and an AI agent to automate all this process, the documentation, and the open source link. That's it from my side. Thank you for your time.